our new amazing automatic path planning. And then we talk about how we take virtual robotics into the cloud. And then we run off, talking about the business modelizing and a Q&A session. So a lot of things. Let's get started, and let's get the party going. And let me start by this, to introduce a little bit to RobotStudio. And don't be afraid. I mean, it doesn't, sometimes the Bizaboo makes, the movies, etc., a little bit jumpy and so forth. But this is really how we use RobotStudio. It's an offline simulation tool where you test and validate your automation solution upfront. You simulate, you verify everything to preciseness. And it's not only about the robot motion, it's also about the configuration, about the handshaking, the safety, the sensors. You simulate everything to preciseness. And this is usually the best way, to optimize your utility of the robot. And you test everything as much as possible upfront. You verify it to speed up the commissioning, to reach up to full production as fast as possible with the desired quality. So that's one part of course, of the offline program, what you can achieve with RobotStudio. The other thing is, of course, that you can update and tune and tweak the existing programs that happens down at the shop floor without disturbing the ongoing production. And we do this only for ABB robots. Nobody knows the ABB robots better than us, than ABB RobotStudio. And, the core thing, really, what enables us is, of course, our beloved virtual controller. This is the DNA, this is the soul, this is the building block that we have in RobotStudio. And that gives you the exactness, the preciseness of RobotStudio. It enables you to see exactly what happens in the screen, on your PC screen. It will be identical what happens down on the shop floor, because we have a true digital replica of the real robot software that runs down on the shop floor. So what you see here will be exact same behavior as happening down there. Same motion trajectories, same motion time, same configuration, same behavior, same everything. You even get the same errors. And you should really love to have the errors here, sitting, in your office, rather than down at the shop floor. At the office, when you're sipping out your coffee, and you will make the smart decision. But when you stand next to a robot, try to solve everything. You're not, your boss is screaming at your shoulder. It's kind of hard to make the right decisions there. But here, trust RobotStudio, trust our virtual robot controller, and solve the tasks and problems up front. And if you combine this, with ABB's superior motion control and our rapid language, with our motion control, it always follows the path independent of the speed, and the rapid language where you can do the calibration and go from offline to the online world. We have the perfect toolbox for you to do this. And RobotStudio, I usually show this. We try to support the entire life cycle of our family of products, and both from the initial sales, proposals, engineering, commissioning, everything to the supervision operation of a robot. And we doesn't really care if it's a real or virtual robot. Since we have a true digital replica of the real one, we doesn't care if we connect the real one or to the virtual one. We get the same stuff. We get the same behavior. So I say that is like the super strength of RobotStudio. Before jumping into the highlights, I will show some of the key functionality that has been part of the product for a long, long time. It's very, we always want to talk about the latest, greatest stuff, but here we have a bunch of features that really solves the purpose. Really solves the needs of what you can do in RobotStudio. We have the signal analyzer. I will show a little bit later on this one, but they can, visualize what happens really to the robot. Physics to simulate the cables, they simulate the physical behavior of the complete of the cell. Jobs, working with the entire fleet of robots. We have the full-blown rabbit editor. We can put breakpoints, step through the program, into preciseness to create the perfect best robot program. And of course, using the CAD geometry to generate the robot path, perfect alignment, using edge and surface and so forth, ideal for that. Virtual commission capabilities, connect to the PLC, test the safety, test everything of your automation system, and do that up front before you deploy it. Sweat volume, I will show a little bit. Then we have station viewers how to create, amazing proposals and share that with others, together with the virtual reality where we can invite others to collaborate, or we can do, lead through programming as well in immersed world. So I just, cherry picked a few things and just give you some insights what we can do, and you can explore it a bit later on, but there is a rich flora of things that we actually can provide. I will show one thing, and that is something that we have been working quite much around the latest, and that's about safety. Because safety has come more and more into consideration right now, and that's pretty much due to this fact that we have man-machine collaboration, people getting closer to the machine, and we need to separate them. Before, when I started, for 25 years ago, then we talked purely about the robot trajectories. That was pretty much what the tool was all about. But now it's very much about how we can simulate and do this, test the safety into preciseness. And in this case, you can see we have a laser scanner that detects when a human enters the robot, and the robot slows down, and the red area, it stops. So that's really one thing. And here comes also the virtual controller into play. But how do we create and how do we set up these safety zones, the safe move zones? Well, we have another feature which is kind of amazing, which is called the stop position simulation, where we can visualize the stop preciseness at every tick thanks to our virtual controller. And we can create the stop position volume for this one. And when you have this volume, you can create the zones or the fencing around this. And that will usually tend to decrease, to shrink the footprint of the cell. Because otherwise you read your brochure and you end up, designing the cell for the super worst case and end up with too big cells in general. So I thought about doing a super fast demo, showing how this could look like. So I just bring up a station. And in this case, I will use the signal analyzer and I will set up some signals to subscribe on this position. So I just start subscribing on them, and then we have the signal setups that turns on a bunch of signals that we can extract out from the robot controller. And just to give you one idea as well, then for this signal analyzer, we can also see the energy and power consumption, which is of course very interesting, especially now when we talk about sustainability, and we can measure those as well in the signal analyzer. But in this case, I will just, turn on a few signals. I will run a simulation, and robot, plays a stupid, simple robot program in this case. And I will bring up a new feature that we introduced last year, and that was for like the playback things. And that is, let me see if I can just talk it here. And that gives you an idea that you can move around, with the latest recording. And you can also turn on the stop positions, and you can see that here at each of these ticks, you see exactly where the robot will come to a stop. So I just drag that, and we can also measure to say, hey, how far away? And you can see moving around, it needs almost 2 meters to come to stop with the speed, load, and inertia, and so forth. The next thing that we did as well is that you can export, that you create the swept volume, and we can choose to include the stop positions or, just the pure motion itself. So I've just prepared it, and you can see that we have a swept volume around this one, and this one you can export to, to your engineers to set up the fencing, or to robot program, etc., to set up where the safe move zone should be. So, combining the signal analyzer with the playback, and we have this top position, opens up those possibilities to create the perfect safety engineering inside RobotStudio. Cool. So that was pretty much what I was, starting to mention about the old stuff. But now let's move into the next things. And the first highlight is something that we've been dreaming of for a long, long time, and that is about the automatic path planning. Just think about that when we started, that was like a dream to have the system to be able to create the program for you, because you actually do pretty much the same thing in the virtual world, in the offline program world, as you do down on the shop floor. You teach the program, you let the robot move, you do the teach, etc., but you do it completely offline. And that ends up in a kind of, jerky, sometimes non-optimal movement. But instead, let the system, do it for you. That has been like the dream, to let the RobotStudio to automatically create the optimal path in some way. And this is something that we've added now in the latest releases. And that will be, the concept from now on that we include, and we use this functionality, to lower the threshold, to speed up the engineering phase by using the built-in automatic collision-free path planning. And the whole idea with this one, and this is something that will affect every feature that we add in RobotStudio, is that we more should tell the robot what to do, not how it should do it, because we should let the system, solve it for you. And that usually means that when the system creates it for you, of course, we spend less programming time, but we also end up that we have shorter and smoother movements. And when you have shorter and smoother movements, it will usually end up that you have faster motion times as well. And also that it consumes less energy. And also that you stress the robot less. So you can see there are a lot of benefits by using this automatic path planning. And I have like an example here, and you can see this is like a standard program that you see to the left. This is something that we have created. And you can see there are stop points, some fine points, there are linear movements, and it takes kind of long time. Compare that what is being automatically generated to the right by RobotStudio. You can see way much smoother movement. And we have decreased the cycle time by half. And we also reduced the energy consumption by a third. And this is just, one tiny subsection of the entire program. And of course, if you apply that to the entire station, entire program, you can just think of how much cycle time you can gain and how much energy you can save. So I hope this, gives you some insights. And I'm really excited about this. And I will now do a few demos to show you how to use the tool and how easy it is to use the automatic path planning. So I'll stop the presentation. I will jump into this one first. So here we have a super simple cell, not very realistic, but still a very simple cell. And there are 3 positions that we should go through. This robot holds a tool and a big rod, and it should jump into this cage here, and then in the end move into this shelf with this rod. And this is extremely tricky movement, of course, to do, and not very easy to program. So I actually compared and gave this task to my colleagues, my super expert robot programmers, and say, hey, let's compete a little bit on this one. I ran it through automatic path planning in RobotStudio, and you program it manually, and you can only guess who won. Of course I did. No, but the system, of course, beat up, because this is a really tricky thing, and it ends up that we could create the robot program much faster, less cycle time, and with less targets as well. So just let me show how easy it is. So we open up here, we have this new feature here, which is called collision-free path. So you open up this one, and here you can select the target. So I just click on, here's the first target, I just add the next, and then I add the last one. And by specifying those, I set the sequence, where to go to and where to end. And there are a few other parameters, it's not much to add. You can say the only thing that you need to specify is pretty much how much clearance should I have against the other objects or against myself, against self-collision. And then I just press create. So now we calculate the optimal path, and boom, we have it. And let me just run it to give you an idea. And we create a bunch of joint targets and absolute joint moves. So I just move along the path like this. And you can see the robot pulls up the rod and have this clearance and moves into the cage, swings around the rod, and then pulls it out again and bends it and twists it into this cage. and voila, we have, a working program in just, a few seconds or minutes. And that is really hard, of course, for human being to compete with and to do. So I think this is like truly amazing. And actually how we do, there are a few settings. And what you actually do is that we describe and use collision geometries in the cell. So we have what we call convex hulls that we generate based on the geometry that is in the cell. And we use that to plan. And you can decide if part should be part of this collision detection or not, and also how accurate the model should be. So you can have different detail levels and so forth. The less accurate, of course, it faster will go to calculate the path. But this is really how you do it. Bring in the geometries, you generate the collision geometry details, and then create the path. I have a few other samples as well, so I will just bring them up. The other one is this one, where we actually can plan for multiple targets. So in this case, I will use this robot. I will start from here, and I will visit all these targets here. Pretty much just the same example before. So I just, select the targets. I open up the path planning, and you can see we have a single path. And I will also make sure that I return to home after I visit all the targets here. So we go from home and visit all of them, and I just press create. And the system creates, the path for you in the way that we have selected and ordered the targets. But you can already see just by looking at it, it's far away maybe from the most optimal way. We go here, etc. and so forth. But instead, why not we let the system optimize, the path, the routing? If you have no dependency really that you have to go there before the other one, let's calculate the shortest path for you so you can optimize the order. So I just select this box, I press create, and what's happening now is pretty much like, traveling salesman problem, that we weight the different parts and we take the one with the least weight. And what we ended up with is this guy. So I just turn off visible, the first one, and you can see that looking at this and you compare to this guy, you can just by looking in the eye that you see that this is way much shorter than the previous one, this one, of course. So you can also use the collision-free path planning to optimize the path in the shortest movement. Another thing I also would like to share with you is the possibility to create multiple paths just by one click. And in this case, I have a dropping position, and the thing I would like to do is that I would like to go and visit all these different bottles here. So I select this one, we do the same thing, select it, and I say create collision-free path, but we go to this other tab which is called multiple paths. And that means that we start from this drop target here, and you should go and visit all these targets. And we start from here, go pick, start from here, go pick, but we also would like to make sure that once you have done the drop, we should go back to the start position. So we say return to start. I can speed up a little bit, and we say create. And once I press this, you will see that we start creating all these paths automatically for you. So it's kind of cool that it just, by one click can generate, tens of paths in a few seconds. Of course, you maybe would do this in a different way. Of course, you would have some offset and rel list, etc. when you do the robot program, but you can easily see how fast you can do this. And I just do like this. I will do some synchronization, push this down to the controller, and, start playing around like this. So robot will go there, go to each of them, and boom, we have done a super quick robot program. Okay, I'll stop there, and I have one more demo for this collision-free path planning that I would like to share, and that is this guy. And it's a little bit different because this is more of, let's see, when you have a dedicated cell, and in this case, we go from the in feeder to visit a different machine and drop the part to the out feeder. And think about this when you have like in the sales phase, more or less, you say, hey, I would like to create a very quick, program just to show you how it could look like when you run this, to give some ideas of the cycle time, etc. And this is really much more how we say, tell the robot, tell the system what did you do, not how to do it. Of course, this is not most the trickiest program that you can do, but still, I will show you how easily you can do, and also think about it when you are in like a sales phase. You want to create something kind of quick and fast. So just as before, I select the target, I open up the collision-free path, and I just say, hey, I would like to add a bunch of it. And the story is right now that I have a few targets prepared already that I would like to go. So usually you have to go to an approach position, you go and do a pick, and you do departure. So it's pretty much that you go to the weight, you go to pick, you go to the weight, okay? And I do that for the same for all of these machines. I go to machine 1, I go to machine 2, I take machine 3, and then I will drop it at the out feeder, just like that. And then I will return to home. So just have a look at the sequence. So here you specify more the sequence: home, the in feed, machine 1, machine 2, machine 3, etc. I just speed up a little bit and press create. And we created, just like that, a super simple path, but still something that could be very nicely visualized to the user, to the customer, whatever. So feed the machine and run through the cycles just like that. In just a few seconds, we created an automation program for this specific setup and return to home. Good. So that's pretty much it about the collision-free automatic path planning. I hope you think that it's interesting. I really would like to encourage you to test it and try it out. As I said before, we have just started the journey on this one, so we see much more things happening on this side. But for me, this is one of the coolest things that we brought to the market for a long time. And now, next thing, how we'll be taking RobotStudio into the clouds. Cool, isn't it? I know I've seen this 100 times, and I love it. I think it's amazing. This was like a launch video for RobotStudio Cloud when we launched it end of last year, but it also has a really, it looks, besides looking great, it also have like a story really to tell. And if you think about it, really starts, and that's like how the flow is thought about it in this product. And it's about that you start from the desktop product, you start from the scratch here, you create your automation product, and you upload it to the cloud. And here you can start collaborating with others. You can invite others to this automation product, to this solution, and to collaborate together with you. And you can either use the desktop product or the cloud tool, but access the same data. And they use the tool that they feel most comfortable with, and the tool that solves this task most easily for them. But there are no dead ends. You can use it whatever you feel most comfortable with. And then when you're done, you can simulate and test everything in the cloud environment, and using our virtual robot controller, that we also brought into the cloud. And you can be sure that it works just as it does on the desktop and as in reality, and you push the changes down to the robot. So this is what it's all about, to creating this ecosystem that we all have, a platform where we can collaborate and work in parallel. So if we would like to compare with something, I usually say this is pretty much the same principles as like we have, for example, Microsoft Office products. For example, when I created this presentation in PowerPoint, of course, I opened the desktop version of Microsoft PowerPoint. Then I upload it into the OneDrive, and then I can invite others to review and add content to it. And if they just want to do minor changes, they will probably use the built-in web application, just as we have the RobotStudio Cloud app. Because the RobotStudio Cloud app is just built for, tuning and editing existing solution. And then, of course, you validate and push it up. So that's the whole idea, that we can work together on the same product. And of course, bringing virtual robotics into cloud, bringing the virtual robot controllers into cloud, that opens up, of course, tremendous opportunities for the future. We all know what happens, with AI, machine learning, reinforcement learning, and they run in the cloud. And of course, to apply that to your automation product, that is a lot, what you can gain from. And then, of course, we can have, spawn out hundreds, maybe virtual robot controllers, to optimize and to work with that solution. You can just think about what will be possible in the future. And this is what what it's all about. We have built this, we created this, to be able for the next step, for the future part. And we have a few things that really we like to push for with the cloud thing. The first way, obvious thing, is about the possibility to collaborate. Just as we sit worldwide now. We have attendees from all over the world. In the same way, we have organizations that are working from everywhere. And that means that you can sit anywhere around the world, working on any device from any place, and enhance your robotics solution. The other thing that we have worked a lot with is that it's tailored for specific use case, this cloud application, and it is about edit and tuning an existing robotics solution that is created from a desktop. So we create quite an easily and simple, straightforward user interface, and we just cherry-picked the function that is really needed to edit and tune the program. And I will soon demonstrate that. But that's the whole idea, to lower the threshold for automation. RobotStudio Desktop can be kind of tricky. It has grown with additional many features and functions over time, and it's become pretty much like an expert tool for expert users. But with this, we address new users and new segments that moves into robotics. And the third thing is, of course, about the traceability. When you start collaborating, there will be a lot of different versions flooding around. But it's not only that. One of the biggest challenges in automation is, of course, to keep track of the versions. Which version is actually running down a robot controller? Who did the latest updates? Who have done the changes, and why did they do it? And when did it happen? And why does my, cycle time increase and my quality decrease? To have those traceability, have that knowledge is something extremely vital. And in software, where we come from, this has been, a no-brainer for decades. But we're taking the same principles and brought that, into robotics programming. So we use a Git repo, and we have it packaged in a nice way with a nice user interface on top of it. So make it, quite streamlined, quite easy to use, because version control can be kind of messy otherwise. So I will demonstrate that as well. And we also, of course, taken our beloved virtual robot controller and brought that into the cloud to make sure that what you see there in the virtual, in the cloud, is exactly what happened down on the shop floor. Time for another demo. I hope you are ready for some cloud stuff as well. So I will bring up RobotStudio again. I prepared a very simple demo for this one. It's a cutting cell. So I can just, run it. It is apart, and the robot goes down, do some grinding on the side, and just kind of easy program in that sense. But this project or this solution is stored locally on my machine. So what we have done now is that you can see up here in the right corner, we have the possibility for me to sign in as a known user. So this comes with a premium license. If you have a premium license, you will have access to the cloud. And that means that you have your own storage, your own portal where you can upload. And the products are only accessible for you unless you invite someone else to collaborate with you. And I will demonstrate how you do that and how you upload it and how you. So the first thing that you have to do is that you have to share it. So you go here and say, hey, I would like to upload this into cloud. Just as I said, I will just, initial version. I will create this one. As well. Okay, and I start pushing it. So what happens now is that we repackage it into our new product format. We have moved away from the solution format, we depreciated that and moves into what we call a product format. And that is an easier way to make it version controllable. Before, the solution was just one big blob, which is not good, when you do storage or version control. Sorry for this. This is my debugging things on the version controller, so just ignore them, okay? And right now, I changed it to a product format. You can see I'm now as well connected to the cloud. You can see this little marker. And you can also see that if I move in here, look into my cloud storage, you can see here are all my cloud products that I have. Sorry for this guy. And here's the cutting demo that I just created. And you can see there are a few things. Since I'm connected now, we're also connected to the version control system. You can do a lot of different things here. For example, you can push the changes that you have done here locally up to the storage in the cloud, but you also can get changes if someone else has, pushed in the changes. There is some concept about branching and merging, and that means if you work together with several colleagues of you, you have to create your own individual branch or track. So I have the main branch, which I created right now, and then you can have parallel tracks that works together with you. And once they are done, they can test, they can optimize, they can play around with that one. But when they're happy, they can push that, and we call it merge it into the main branch. They can also extract things from the main branch. It's a lot of technicalities, but I will show it a little bit later on, so it's easy for you to understand how it works. So we have everything built in. So if I open up this guy here, so I'll go to the cloud products here, you can see that I'm showing my portal and all my products that I own. And this is the product that I just created. Just having a quick view, you can see where we have some data dashboards with the different cards that I have for all my products. You can see that I am now logged in as Magnus, and I have my storage, how much storage I consume. We can take a welcome tour to just to guide you about what's the product is all about and how you can use it. We also have documentations, tutorials, a bunch of tutorials how to get started. I think that's good for you to try out. We also have documentation. We also have the latest release notes that describes what's happening with the latest update or product. So a lot of good things, that you can use from the cloud portal. But the first thing I would like to show is that when you click on this one to view the product, you can see the different versions. So this is what I pushed up right now, the initial versions. And let me go back to the desktop and do some changes and commit it. And the first thing I would like to change is that maybe I go into the Rapid program and add a few things. Let's see, wait time here. And I make another go to the path. And sure, we can run it. And of course, it will run the path twice. And when I'm happy with that, I've verified it. I want to share it with the others. I can now do a commit. And you can do it from two different places. And you can see I currently work at the main branch right now. And you can either do it from the file where we were before, or you can just do a commit here. So before doing commit, I can also review and see what are the changes that I actually will push as a new version. So I do a review and commit, and you can see there are a few things. I have to save it first, of course. And you can see first, of course, I changed the program. And this guys compare now what the previous and the current version. In the case, I added a few things to the Rapid program. There are also some changes to the station. There are some dates, stamp, etc. and so forth. But if I'm happy with this, I can say, hey, I have to write always a comment to have this traceability. So I added wait time to and a proc call. Okay. And that means we create the new version up in the version control system. Heading back to the project portal, I refresh this one. And you can see here are the changes that I pushed in, added weight. But it's not only that you can do changes in the Rapid program. I can of course do changes to the environment, the station, to the layout. So let me do that as well. I'll make a copy of this piece. This is the guy. I will just drag it a little bit like this. So we say that we have another instance of this one. I'll save it. I commit it. I push it up. You have to label it as an added part. Okay. So that means not only the Rapid, but also the station layout will be now stored in the version control system. Okay, the next thing that I would like to do is add a part in the station environment. The next thing that, of course, I would like to do is start collaborating with others. So I can invite others to work with me. So I just, as you do in OneDrive, etc., when you share, so I just, send a mail, give them the link, invite, and I send the link that, hey, do you want to collaborate with me? They click on this link, they accept it, and they say, hey, I want to join you. The first thing they have to do is to create a parallel branch to work, because they cannot work with the main branch. So they have to create a new one and start working on that one. And when they're done, they can push those changes into it. But let's open up, the how it looks like in the web app. So I take the latest things that I pushed from the desktop into the cloud and open up this in the cloud application. So here you can see the new things that we have. So of course it starts loading the geometry, and we can see that the controller is starting up. And meanwhile, we see the structure, the modules, the path, etc. of the robot program together with the entire robot program that we have uploaded. And you can see here are my latest changes, as well as I have the new added part as well. There are different layouts that you can use. You can have, full screen. You can even close this panels, the side panels, so you can have it the total thing. And, you can simulate, you can run and test everything. So what I would do now is actually show you how easy it is to do some sort of tuning and tweaking. And of course you can, change it by just add it program, but you can also use our built-in, editing of the program. So I'll just scroll down to the program, and when you select one of those, you will see that you get arguments quite easily. So you can change it directly in here in a quite straightforward way. In this case, I changed the speed, but you can also change the positions and the different arguments of this instruction. But I can also zoom in, and you can do some manual changes as well. For example, selecting a position here, and you can see you have a gizmo that you can change, and directly it will be affected into the code by this. Okay, you can also turn on that you want to see the tools, so it gives you another indication how, this guy again, how the actual approach or the angle will be on this one. Okay, so there are multiple ways really to do this and to edit and tune and tweak your program. So once you're happy, you've done your changes, you've tuned the program, you can of course test and verify it. So you can put in a breakpoint as well. So you put the breakpoints where you actually want to be, and you start the program. So now the controller is starting away, and it stops at the breakpoint. And now we can do this stepwise jogging, that you go step by step, looking into a program, ensure that you really do the right stuff and all the changes that you have introduced is working as expected. You can clear the breakpoints, and we can continue to run. So it's just as simple as that. You do pretty much the same thing, but you have kind of slick interface that it does only the things that is needed, right? What is designed for. And once you're done, of course, you have to do an additional commit and store that specific version. So same way, I do commit, changed it, and tuned. Commit. Going back to the version control, updating it, and you will see that we have a new version there, here. So now we push these changes into the cloud again. Everything is in sync, but of course, the desktop, let's see if I can find the right one, needs also to be updated because changes has happened. So I can see that I need to drag those. I have to push those changes, grab them, and update my local thing. So I review it. I'm getting the changes, and I see, hey, a lot of changes happen. So I just take them and pull them back down to the desktop. So we really close the loop. One thing that I forgot to say is, if I go back to the cloud, is of course that you can, of course, as well, push down those changes that happen directly by downloading a backup. Or you can take the NVIDIA modules and just, download them and, bring them to the robot. So we've done the changes, take those changes and push it to the robot. But now everything is in sync. We have updated it, and just for verification, you will see that we have the latest version of the robot program. We changed the wait time and a few other things, and that's pretty much it. Cool. Let me just super fast summarize what you have seen. I mean, starting RobotStudio from the beginning, from the desktop, uploaded it to the cloud product, inviting others to collaborate with you. You have the version control system behind you that keeps track of everything you do. So you are always, not affecting the main thing, and also have everything in sync. If you want to try this out, I mean, if you have a premium license, I mean, you're ready to go. If you don't, we have now a way to start, to try it out for free. And you can just surf into our website. Let's see if I can bring this up to the RobotStudio website, to RobotStudio Suite app website. You can either go to that you can try it for free, or you can go on to the cloud specific site. So you just go in there and say, hey, let me try, and you have to sign in and try here. Okay, if you don't have an account, you have to create one. It takes 30 seconds, and then you test it and you're ready to go. And there is a sample station product that you can try out there. So after the demo, try it out. Okay, last things, the last few slides before we enter the Q&A session, and it's a little bit on the licensing and option. And as I've been showing now, we have created a new family of products, complete suite. The desktop, the cloud, and we also have the AR viewer. And if you use the premium functionality or premium license, you will have the cloud functionality included. And the cloud functionality, cloud feature is nothing that you can buy individually, or you cannot, live without it. You have everything in common. So it's just any other feature like the rapid editor or signal analyzer. So the desktop is, the full-blown engineering tool, and then we have the cloud tool, which enables, collaboration and version control, etc. And then we have the AR viewer free of charge, which you can download. And this is a very nice way to visualize your simulations and to show them. And talking a little bit on the licenses. So as I said, we have a few trial licenses. We have the Try Cloud that you can start testing today. And we have a free trial as well for 30 days that includes the entire thing besides the cloud, but then you can use the Try Cloud. And then in the bottom, otherwise, of course, we have this freemium. Free of charge, you can use it to configure and program the robot, the basic needs, what you need really to get the robot started. But if you need more advanced things, you have to pay an annual fee to get started, where you get the advanced programming things, you get the simulation capacities, and also the cloud features on top of it. And then, of course, we have a bunch of CAD converters, so you can import different CAD models and CAD formats. And we have some process-specific add-ons, which is called Power Packs. So if you're interested, if you're not, a RobotStudio user today, surf into our website or talk to your local ABB sales contact, and they will give you a good offer, I'm quite sure. Last slide before entering the Q&A. So what have you seen today? First, of course, the big things is that we're taking virtual robotics into the cloud, enabling collaboration, simplification to lower the threshold for robotics, and also the traceability, the built-in version control. So I think this is truly amazing, and we really, build something for the future. So that is one of the main things that I want you to bring with you. And the other thing is, of course, the automatic path planning to speed up the engineering phase by using RobotStudio to calculate automatically the collision-free paths for you. Way much smoother and way much more energy efficient compared to doing it manually. So download it, try it out, and I hope that you have received some interest on your side, and also some of the old stuff that you maybe have missed. Try it out. And that's pretty much it. I've been talking for a long time and demonstrating many things now. So I hope there are a few questions now in the chat. And Arvid, please.
Yeah. We had some questions come in as you were doing your demo there. So we'll start with those that we have to our participants. We have about 10 minutes left here. So ask your questions in the chat and we'll try to get to it. The first question that we had is they want to see the rapid code, what it looked like while you were running your demo with the automatic path planning.
Yep. So I can bring this up. So if you look in the rapid code, if I just take one of these samples that I created. So what we actually is creating right now is MoveAppJ target. So we plan right now in the joint space. So we create joint targets. And that means that we create them in sequence like this. But we are also looking into how we can plan in linear space, and also how we can inject, of course, this is just a pure motion. what will happen as well when we come to the actual positions, etc., and so forth. So we can have some post and pre conditions as well happening. But right now we plan in joint targets to avoid singularities, etc., and so forth. So this is the outcome of the automatic path planning.
Perfect. Thank you, Robert, who asked the question. I hope you're happy with seeing a bit of the rapid code there. Of course, you can dive into that even more if you would like to. So moving along here, Renee wants to know if it's enough to import geometry, for example, like an .stp file, or is there anything else you need to do to use the automatic path function?
Of course, you need in some way. Yes, it is enough. We can actually take even point clouds, and we can even take meshes and so forth to plan. So you don't have to have a brep, etc., things like that. You can have less information to plan for it as well. So we support that, but then because we take it can be mixed as well of both static geometries, full representation, but also meshes and point cloud as well that we can use for the automatic path planning.
Perfect. Thank you very much, Magnus. Moving along here, is there also an option to add virtual PLC controllers?
Yep, I was extremely fast on this one, so let me go to. I'll just stop here, and I will just bring up. Maybe I have that in as I know I have something in my backup here. Yes, because virtual commissioning, we usually talk about that as one of the big enablers, and this is something that you can we are really focused, of course, in the robot program by itself, but that's just one fraction, just one part. You usually have a PLC, which is the brain, the master in the production cell. And we have a lot of connection interface that we can hook into to communicate and talk. So we can either talk to a real or virtual PLC through different protocols. So we support OPC, OPC UA, and also CIMID. That's a Siemens protocol as well, to be able to connect to either virtual or a real PLC. And in this case, I just want to show you that while we talk, you can see the operator panel, and it runs the actual PLC code. That means that you can not only test the robot program by itself, you also test the handshake between the PLC and the robot and safety, because that's actually where you usually screw up. The robot moves as it should, the PLC program runs as it should, but what happens in the interaction between them? So yes, there are a few ways to communicate and hook into the others, just as you can see. And in this case, we actually do a virtual factory acceptance test of this. So we go through step by step and to test and verify. So I hope that answers this. So please explore it. We have a lot of different things, and also now in this case we have the HMI to run the true application and the production environment down there.
Super, thank you. Moving along here, Lucas wants to know, how about offsets and retool points? Will they also be visible in the simulation in this new RobotStudio version?
No, it will not, unfortunately. This is like a tricky thing, really, to especially when it comes to offs and rel tools and so forth, because it is a little bit of a challenge to do that, but it has been a long time on the wish list. So yes, we are planning, we think about it, but it's not really there yet, and also a little bit tricky some of the offs to see how to interpret them, because you have to analyze the program some ways to do it. So no, not there today, but a really good thing to really include. So I appreciate that feedback, actually.
Yeah, perfect. Something for you to work on then.
Exactly.
if you don't have anything already.
No, it's completely empty.
Perfect. All right. So there was also a question about the cloud storage and the size of it.
5 GB per default right now. Yes.
That was actually answered in the chat as well. So that was correct. Well done, Emil, who answered that in the chat. So do you need to buy the cloud storage, or can we have our own cloud storage?
Well, we have designed it like this, that is part of the of the ABB cloud storage. We use the Microsoft Azure as the storage, so we have our own ABB Robotics cloud storage. So this is what you really get out of the box today. Then, of course, we architect it in such a way, because I know this is like a hot topic really, that people want to have their own cloud storage. So we have architectures in such a way that we can host it in, other custom storage, but that will come a little bit later on, and also with another type of cost, of course, that is associated with it. So out of the box, RobotStudio Cloud is part of the Robotics cloud storage.
Yeah, there was a follow-up question there, if it's a one-time buy or if it's a subscription-based.
Subscription as well. Subscription, same as the premium license. It's the same license as RobotStudio Premium.
There was also a question: how is IP of the project secured?
The intellectual property. Just as we use daily. We trust very much on the things that we upload to Azure. Just as we, as a company, ABB, we have everything in the Azure cloud, and we have, from the day we started to build the RobotStudio Cloud, we had really thought about the security. We built it in from the really beginning, and the data that you have, that you own, is only owned by you. No one else can access it. Not we, not any third parties or anything like that, unless you invite them. So it's no spillovers. It's only addressed and accessible by you.
Perfect. Thank you very much. Next one is a good one. Merging text code is easy. How about merging differences in models and models locations?
Yeah, it's a bit more tricky thing, of course, and it really depends what type of changes. But yes, we will be able to merge certain type, of changes to the layout, and also try to solve them. But it also depends. So that's why we created this new product format, really, to say, hey, this object can move like this. Yeah, we can solve that, and we can merge that. So we have made another representation that will make merging way much easier compared to others before. But still, there are probably some edge case that will not be able. But yes, we have really thought about that as well in the cloud product or in the version.
Perfect. Next one, start with some good feedback. I find the RobotStudio the best simulation tool, but unfortunately the latest developments have made it much more expensive. For example, the cloud solution has to be bought as a paid option if you really need it.
Yep. Yeah, it's really part of the premium license, I would say. So that's you see all the things that we've added to the product right now. We are demonstrating with the automatic path plan and the cloud things. They're all part of the same subscription, really, and we have added a lot of valuable, extremely useful functions to it. So it's not that you can choose either or, etc. But I understand we have taken quite, big jump lately, but I think you should really, it has been quite underpriced for a long time, I would say. But please, have a chat with your local sales guys, etc. about this. I will not, go into the individual ones, but yes, there has been a big change, but it's not either or. You have to have both the cloud and everything involved into this one. But I will not talk too much about that right now. But please talk with your local sales contact. I think it's the best.
But Magnus, no webinar is complete without the questioning of pricing. So
of course, that's why we're here.
Yeah, perfectly. That's the way. So Nicholas has a question. Are smart components supported in the cloud?
No, not yet. Not yet. So you can only run not smart components of physics yet. This is something that we work with, and it's kind of quite tricky things. But there will be a few things that I soon will be able to share with you, what we can use and what you can see in the cloud later on. So a little bit of a cliffhanger there on that.
Perfect. Getting to the end of our questions here. I see we are a few minutes over our time, but let's stick it through and try to finish these off. Have you ever thought to develop a power pack for thermal spray coating?
No, not really, but that's an interesting task really. And what the beauty is, it's really challenging for us sometimes to keep track of all these new applications that happens. But the Power Packs that we develop, we have an SDK and API on top of it where anyone can develop. So, we have the best community right now, listen to it. So if anyone is thrilled to develop that, please, use the API and bring that to the market. Maybe it's a business opportunity as well to do it, but we have not planned to do it.
Oh, great, thank you. So we have a last question here, and it's a follow-up on the virtual PLCs. Can the virtual PLC run in the same environment?
It really depends which brands, etc., and so forth. I mean, if we talk about Siemens, etc., where we have their virtual PLC, I think they can run everything on the same machine. RobotStudio and SIMIT has to be on the same machine because they use shared memory to exchange the data. And then the virtual PLC can run on a separate machine. So it really depends on the different brands and what they use and what type of technology actually they're using.
Leon, who asked the question, put the brand, it's B&R. He put it in the chat.
That's a good one. Yes, and they can run on separate machines if needed. So usually we've done that a lot of things now, but they run on a separate machine. We use OPC UA, we use Automation Builder and RobotStudio to communicate and to work in parallel. And that runs smooth, really good. So yes, I would say that's a good one.
Great. So that was the last question. So it's time for us to close this session down. I'll hand it back to you, Magnus, for some final thoughts and perhaps some key takeaways from this session about RobotStudio Cloud. Go ahead.
Yeah, thank you. And first of all, I want to say as a warm thanks for everybody to join this call, everybody to staying all the time and following the demos. And I really hope that you thought it was interesting and that you find something that could be useful and fruitful for you. So really grateful that you all made it. And please, surf in after the webinar here to try the new cloud or to download and test the latest and greatest of RobotStudio. Hope to see you soon, guys, again. So thank you very much for participating and have a good rest of the day. Thank you.
Perfect. And thank you, Magnus, for joining us. And I see the chat is full of thank yous. So from our side as well, thank you very much for joining. We do hope to see you again in future and upcoming ABB Robotics webinars. But that's it for now. Bye-bye.